Hi, in this video we're going to talk about how to graph the basic tangent and cotangent functions. So let's go ahead and start with tangent. First thing we're going to do is make a table of values, some of these special values that we have, of special values of x. So tangent of 0 is 0, tangent of pi over 6 is square root of 3 over 3, pi over 4 will give us 1, this one is square root of 3, pi over 2 will be undefined. 2 pi over 3 will give us negative square root of 3. 3 pi over 4 is going to give us negative 1. This one is going to be negative square root of 3 over 3. Pi will give us 0. 7 pi over 6 will give us positive square root of 3 over 3. You're going to get 1 here, square root of 3. At 3 pi over 2 it's going to be undefined again. At 5 pi over 3 it's going to be negative square root of 3, negative 1. Negative square root of 3 over 3, 0, and this one's going to be square root of 3 over 3. Since we're going to be graphing it, let's write it their decimal approximations. This one's 0, this one's 0.58, it's 1 obviously, 1.73, undefined obviously nothing, negative 1.73. This one's going to be negative 1, negative 0.58, 0. This is 0.58, 1, 1.73, negative 1.73, negative 1, negative 0.58, 0. And this one is going to be 0.58. So let's go ahead and plot these points. So do it with the pen, make it a little neater. So we have 0, 0. At pi over 2 it's undefined, so at halfway there at pi over 4 it's going to be 1. At pi over 6 is going to be 0.58. Here is going to be 1.73. Then we have at pi our value is 0. At 3 pi over 4 it's at negative 1. And this is 1.73. This one's negative 0.58. This one's going to be 1. This one's going to be 0.58, 1.73, etc. So what we're going to get here is going to be something that looks like this. And here we're getting something that looks like this. And we're going to get a bunch of branches that are going to look like this. And over here, of course, is going to go like that. And then there will be some more on the other side that are going like this. So let's see what it looks like. These are this graph here is the graph of tangent. Remember, tangent is sine over cosine, so wherever cosine is 0, the graph of tangent will not exist because you cannot divide by 0. So you see where we have tangent is 0, I'm sorry, cosine is 0 at pi over 2, and we have a vertical asymptote here, and then at 3 pi over 2. So that's what it is. But so the dashed curve is the graph of cosine, and the solid branches, that's what the graph of tangent looks like. So it's a periodic graph also. So what do we need to know here about this? What we need to know is, let's discuss domain. So domain is going to be points where x, as long as x does not equal the values where cosine is 0, so x cannot be pi over 2 plus pi n, where n is an integer. A range is going to be all real numbers, negative infinity to infinity. And the function is going to have its vertical asymptotes at every point where this happens. So it's going to be x equals pi over 2 plus pi n. This function is going to be increasing on its entire domain. Okay. It's going to be decreasing. It doesn't have any intervals where it's decreasing, so there's going to be none. It's going to have x-intercepts at points that are going to be x equals pi n, right? It's going to have a y-intercept at the point 0, 0, and it doesn't have any relative min or relative max because it is a strictly increasing function. Let me show you this one more time. So it's only increasing, so no relative min or relative max, and there are vertical asymptotes at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and then negative pi over 2, negative 3 pi over 2, and so on and so forth. This graph is also periodic, and its period is pi. Okay. So let's go ahead and take a look at the graph of cotangent now. So we're going to do the same thing. We're going to start with making a table of values and go with that. So when cotangent is 0, it's going to be undefined. Pi over 6. I'm just going to write this quickly. Square root of 3, 1, square root of 3 over 3, 0, negative square root of 3 over 3, negative 1, negative square root of 3 at pi. It's undefined again. 7 pi over 6 square root of 3, then 1, then square root of 3 over 3, then 0, then negative square root of 3 over 3, then negative 1, negative square root of 3. Here it's going to be undefined, and then square root of 3. So 1.73, 1, 0.58, 0, negative 0.58, negative 1, negative 1.73, 1.73, 1, so it's going to be 0.58, 0, negative 0.58, negative 1, negative 1.73, and then this one's going to be 1.73. Right. So we're going to go ahead and graph it. So it is undefined at 0. At pi over 4, we're going to be at 1. So at pi over 6, it's going to be at square root of 3 over 2. Here it's going to be at 0.58. And then, so what you're going to notice is that this graph is going to look very much like a mirror reflection of the graph of cotangent. And there will be branches going like this. Okay, that's what it's going to look like. And let me show you a more precise graph. So that's what we have. I want to remind you that the graph of cotangent is cosine over sine. So wherever sine is 0, we are going to have a vertical asymptote because we cannot divide by 0. And so I have the graph of cotangent and the graph of sine graphed together. The wave, the dashed wave, is the graph of cosine. And you can see wherever the cosine is 0, wherever sine is 0, the graph of cotangent is going to have a vertical asymptote. So it happens here at 0, then again at pi, and 2 pi, and 3 pi. Okay. So let's write this summary here of all the main features. So the domain is going to be it's wherever sine is not 0, which is going to be in our case, x cannot equal pi n. So it's not going to be at 0, pi, 2 pi, where n is an integer. The range is going to be all real numbers. Vertical asymptotes will be at every single one of these values, so x equals pi n. This function is not increasing. It is decreasing on its entire domain. It has x-intercept at the point pi over 2 plus pi n. Has no y-intercept, and it has no relative min and relative max. And it also has a period of pi. Okay, and that's what it is.